We are in AP Calculus. Today's date is Thursday, February 27th, 2020. We were talking about general, absolute, extrema. We are on lesson 3 out of 3. This is the final one for Unit 10. Then we have our second to last unit right now. Final unit is Unit 11, and that only has 5 lessons. So we have, including this, 6 lessons left of the entire year.
Yeah.
Oh my god.
Asterisk, because that's for AB. BC still happens, right? In the background.
I haven't done any BC.
It goes fast.
Sheets of BC you gave me.
So, all right, our objective today is to do what, Claire?
To find the absolute extrema of the integral of a graph.
Yeah, so not only the extrema, which you've found before, I can find the minimum, I can find the maximum, but yeah, what happens if I am talking about the integral of a graph now? So, parts of the integral, let's do some review. Where do I have mins and max? Where are my relative extremas?
Right there, right there.
Right there, right there. I think you're pointing to this spot right here and that spot right there. Is that right, Gio? Yeah, so
Does that count on the y?
yeah, that one also counts. We'll call that. So what are these called again? Relative extrema. So this is a relative min.
No, it's not a. Oh yeah, you're right.
This is a relative what? Relative. You guys got this? Maximum. And this is a relative. Be nice.
You talk to me.
So there's a nicer way of asking them, like, Gio, can you please stop talking to me instead of telling them to shut up? All right. Anyway, we have relative min, relative max. What else do we need to say? Okay, let's assume that this is a graph of f of x. That way I can talk about it in notation later. I can take the integral. The integral normally always has a beginning for AB calculus and BC usually too. So let's go ahead and draw a line. We'll say, I don't know, start there. We'll start at A, and then I might not have an end. Okay, so those are the relative min and max for the function. But now I want you to think area. Think integral. Where does the integral have a relative extrema, I guess? So let's say between here and here. Where is the area the max? Is it area max between A and this point, A and this point, A and this point? Where is the maximum point?
A and that point.
A and
Right there.
right here?
Yeah.
No. Try again.
Like where the area is max, wouldn't it
Yeah.
just be all the way at the opposite line?
All the way here, yeah.
Oh.
We're trying to maximize area, so as far right as you can. That will change once we start going above and beneath the x-axis, because then we'll have negative area too, right? That we have to account for. This one's pretty straightforward. Yeah, just as long as I'm above the x-axis, go as far right as I can. All right, so as a review of where things happen, because you do need to analyze what's happening on your graph too, where you have a max and min. Where do I have an absolute minima where I have an endpoint, a left endpoint? Where would that happen? In terms of strictly the function, not the area. Think back to just functions. Can you draw a function that has a minimum, the absolute minimum, at the left endpoint? Yeah, exactly. Yeah, start at the left and then go up. It doesn't matter what's going on. As long as you started on the left and then go up, you're good. What about the right endpoint? How could I have the right endpoint be the absolute minimum?
Start from the right and go down to the left.
Start from the right and then go
Up to the left.
up to the left, yeah. So I could even do sharp corners. I don't know, something that's happening like that. As long as I don't accidentally go beneath that point, this is the absolute minimum. These are all relative minimums, relative, but the absolute one is the very most bottom one. How could you have an absolute minimum that doesn't happen at the endpoint?
Use a straight line.
Straight line happens everywhere. If I have a straight line, that's a minimum, that's a minimum, that's a minimum, that's a minimum. All of them are minimum. Yeah. So if you go like this, I have a function that looks like that. And maybe if I want to have endpoints, I could do that as well. So I could have some function that looks like this. Yeah, neither endpoint. Both these endpoints are relative maximum. Maybe that one's the absolute maximum. But the minimum is right here, and that does not happen at an endpoint. All right, try it again. You should be able to do this on your own now. find the absolute maximum now at the left endpoint. What does that look like?
So start at the left and go down to the right.
Yeah. I should be careful about how I draw this. There it goes. What about the right endpoint? What would that look like?
Start to the right, go down to the left.
Yep. And neither. What's up?
Frowny face.
Frowny face.
Alright, so let me get that to it.
I can show you an example that you guys probably didn't think of. And it's something that my Algebra 1 class can show me. Ready? Something that doesn't have any endpoints. Obviously can't have any, if it doesn't have endpoints, then you're done, right?
No, different channel.
It's like a trick question.
I know. And you have to be thinking about those trick questions in AP Calculus too.
Okay.
Does this function ever have a maximum?
No,
Why?
because it goes on forever.
Yeah, there it is. All right. So whenever you're trying to find a maximum or minimum, even when you're talking about an integral, you still need to use a table, just like you did before. The only difference now is is there a difference? I don't know if there is a difference. You're basically still doing start plus change values, and your change value is going to be an integral. You're trying to find when that integral is the biggest. So again, we're going to have t or x values. I'm just going to call them x for now. You want what plus what equals what?
Start plus change.
Yep, start plus change is equal to
N.
the end value. So what if I want to find f of a? How do I fill in this table? Let's assume that our start condition is also f of a. How do I fill in this table? What is our x coordinate that I'm looking for? A. What is the change? Is the integral from a to a of f or f prime?
F prime.
Yeah. In order to match this f, this has to be f prime. F prime of,
A.
we'll call it f prime of x because we're dealing with x here. F prime of x dx. What if I want to find, I don't know, let's choose a point up here. Let's say this point right here, C1.
So you do C
C1,
plus F of A.
what's our start position?
F of A.
F of,
C.
f of a still. It's always the same start position for all of these.
Twice.
Sorry. Integral from
C to A, or A to C.
a to C1 of f prime of x. And that will give us what?
The N.
F of C1. Yeah, just getting the patterns down here. And you keep doing this over and over again. I guess if I'm being accurate about this table, I probably want to find critical values only. So C1 is good to put randomly, but it makes more sense to have where are my critical values. That's what we always put in our table. So I'll have a critical value 2 here. So I'll call that C2. So the next critical value I want to check, C2. Again, f of a is my starting position. It's going to be the integral between a and C2 of f prime of x dx. And that'll be equal to f of C2. All right, so we have our start. We have our critical values. What's the last thing that we have to check for our table? Start, critical values, and end. Yeah, so if you have an endpoint, let's just go ahead and say I ended right there. Let's call that B. Then you have to have your end. So I don't need to finish the table here, and neither do you. If you want to, you can. But the main thing to take away from this is it's the same process over and over. We need to make sure you have your start. You need to make sure that you have your CVs. Technically relative extremas if we're being technical, and then your end. You need to make sure you check those 3 things over and over again. Questions? We'll really see what's going on when we start working on homework.